So, your blood test results just came in today, and I'm sorry to say this, young man, but it looks like you have diabetes.
Wait, what's diabetes?
Well, diabetes means that the ability of your body to produce the hormone insulin has been impaired, causing the glucose levels in your blood to rise. But don't worry much, because all you have to do is come in for regular shots of insulin, and I'll give you a diet plan to follow from now on.
So doctor, can I still eat ice cream and cakes?
I'm sorry, maybe you do have to cut down the ice cream and the cakes because these foods contain way too much of sugar.
You said my glucose levels are high. But why can't I have sugar?
Well, actually, sugar contains glucose. Let me explain further. As I mentioned earlier, sugar contains glucose. What is glucose? Stay with me and we'll dive deep into the structure of glucose. Starting off with the IUPAC name 3R4S5S6R6 hydroxyl methyl oxane 2345 tetrol and its common name dextrose. Glucose has many uses, mainly in the food industry as a source of energy and medical purposes as well. In this video, we'll focus on one of the uses where glucose is used as a source of energy by humans, plants, and animals too. During glycolysis, a glucose molecule with 6 carbon atoms is converted into 2 molecules of pyruvate, each containing 3 carbon atoms. For each molecule of glucose, 2 molecules of ATP are hydrolyzed to produce energy. Next, let's take a look at the structure of glucose. The first thing we would want to know is whether does the structure have chiral carbon. Well, before that, what is actually meant by chiral carbon? Well, chiral carbon refers to a carbon atom with 4 different atoms or groups of atoms bonded to it. Carbon atoms with double or triple bonds can't be chiral carbons because they can't have bonds to 4 different groups. If we look into the structure of glucose, we will notice that glucose has 5 chiral carbon atoms. Each chiral carbon is marked with an asterisk. Let's take chiral carbon 1 or C1 as an example. As you can see here, this carbon atom has 4 different atoms or groups of atoms attached to it. Therefore, it is identified as a chiral carbon and marked with an asterisk. Same goes for the other 4 chiral carbon atoms. However, the structure of glucose has 6 carbon atoms, but only 5 carbon atoms are considered as chiral carbons. Let's see why. Look at carbon 6 or C6. We can see that the carbon atom has 2 identical atoms bonded to it, which is the hydrogen atom. Therefore, it is not a chiral carbon. Moving on to the molecular structure of glucose. Let's start off with the expanded structure. In the expanded structure, all atoms and bonds can be seen. Each bond is represented by a line. This is the skeletal structure of glucose. The skeletal structure removes all hydrogens that would be present. This leaves only the carbon skeleton where each point on the skeletal represents a carbon, together with the attached functional groups. Speaking about functional groups, let's take a look at the next slide to clarify what functional groups are present in the structure. Based on the diagram, 2 types of functional groups have been identified in the structure of glucose. The first one, where COC has been circled, is the alkoxy group which belongs to the class of ether. The next one, where the OH has been circled, is the hydroxyl group which belongs to the class of alcohol. And if you look closely, you will notice that there are 5 hydroxyl groups present in one molecule of glucose. And did you know that these hydroxyl groups are the reason why glucose tastes sweet? The hydroxyl groups with certain orientation interacts with the taste receptors for sweetness in our tongues. This is the same reason why fructose is sweet as well. Lastly, let's identify the classes of all carbon atoms that exist in the compound. Let's take a look at C1. The carbon is bonded to only one carbon atom. Hence, it is classified as a primary carbon. Same goes for C6. Now if we look at C2, it is bonded to two other carbon atoms. Therefore, it is classified as a secondary carbon. Hence, C3, C4 and C5 are secondary carbons as well. Looks like that's all you need to know about the compound glucose. I hope you benefited from this video. Thank you for listening.
Okay, I understand, doctor. I'll be sure to cut down my sugar level. Thank you very much.